Hey y'all, welcome back to Miss Meekin's Mansion. We have another lesson here for us today, so let's get started. So our topic of focus today is graphing quadratics from factored form. So some things we're already familiar with is the word quadratic function. A quadratic function that is in standard form ax squared plus bx plus c. We see this equation when we're given it. We're also seeing it after we simplify our expression. Then we have parabola. That's been our new vocabulary word that describes a quadratic function, which is a U-shaped graph, either opens up or opens down. Now, what's going to be new to us in this lesson is the factored form of a quadratic function. So we just saw our quadratic function ax squared plus bx plus c. Well, here we have a, but now we have x minus n times, sneaky multiplication, x minus n. This is factored form. Think about when we're factoring, we're breaking apart our quadratic function into two separate entities if necessary. And so now we're working with the factored form of this problem. Think if we multiplied x times x, we would get x squared. And that is quadratic. Okay. Then we have this a, which is the same a in our original function. Here's our leading coefficient. Talked about that word in our vocabulary lesson. And it determines the direction. Is it going to open up or is it going to open down based on that number or symbol in the beginning? Then we have our m and our n, which I mentioned already. If this is factored form, then these are our factors, also known as our x-intercepts, zeros, roots, or solutions. All of these words are interchangeable, and we can find those on our x-axis. So we're going to hop right into it with our exemplar model. You will need some scratch paper and something to write with, not just for this video, but also for your independent work. So please make sure that you have that out. So what we are asked to do is to graph y equals 1/2 parentheses x minus 6 times x plus 2. Now remember, we are working with quadratic functions. If we multiply this x times x and get a quadratic, we know that eventually our graph over here has to be a parabola, meaning a U-shaped graph. So that's what we need to come out with when we finish. So in most general cases with a parabola, I'll just draw a small one over here on the side. We know that a parabola could possibly cross the graph twice. Could possibly have two x-intercepts, right? So that might be the first 2 points that we actually look for. And our equation actually kind of helps us with that. Remember, our y-intercept, an x-intercept is when our point crosses the x-axis and our y value is 0. So we are trying to look for what is x when our y value is 0. So this factor form makes it pretty simple to see what could be our possible zeros and solutions. However, we want to solve for when does x equal, what does x equal when y equals 0? So I'm going to do that now. All right, so we have 1/2 x minus 6 x plus 2 equals 0. It's not an equal sign. Now, we are trying to figure out what could x possibly be to equal 0. Now, you see that we have multiple terms that are being multiplied next to each other, and they equal 0, which means one of these terms has to eventually equal 0 for this to be a true statement. Something times 0 equals 0. Now, 1/2 is its own number. We can't ever equal 0, but we can see if, let's use some different colors, x minus 6 could possibly equal 0. We could also have x plus 2 equals 0. Now, we've dealt with this before when it came to factoring and solving for our x-intercepts and our zeros, and we're bringing that same skill up here. Now, I want to make sure that I emphasize x minus 6 equals 0 or x plus 2 equals 0, right? And so we solve those problems, and sorry if the colors are going all crazy. And of course, we add 6 to both sides to get x by itself. So here we have x equals 6. And we subtract 2 from both sides, and we have x equals negative 2. So what are that actually telling us? That is telling us that our x-intercepts, when they cross the x-axis when y is 0, so my y is 0, and my x is 6, or my x is negative 2. And here, they both are, because we can possibly have two x-intercepts for our parabola. Now remember, we're trying to graph a parabola. We're trying to graph a U-shaped graph. So let's plot these 2 points that we already have on our graph. Now, as you can see, and probably what you have at home, is not an exact graph. Duh, but it's okay, because algebra in math, we can sketch, we can make, our own examples to help us understand the question. So that's what I'm going to show you here, so that you can use that for your later works. So I have a blank graph. I have a y-axis and an x-axis. And now I'm going to just add the values on the graph that I need. You can add all the values if you want to, but I'm just going to add the values that I need because I'm just giving a quick, brief sketch. So I have the x-intercept 6, 0. So I'm going to go, 6 is positive, so it's going to be on the right side, and I'm going to just call this 6. Okay? And I'm going to plot a point at 6. And 0. Okay. Then my other x-intercept is negative 2, 0. Negative 2 is on the opposite side of the x-axis, so I'm going to say that it's like right here. And then I'm going to plot that 0. So far we have our two x-intercepts on our x-axis, but we do not know if our graph opens up or opens down. We can infer and we can imply that from our a value, 1/2, but we want to just make sure, and we want to find any points that we can in order to connect these points to turn it into a parabola. So let's keep going. All right, so we have our x-intercepts, but we need another point, and I definitely think that we should plot the vertex. That is our highest or lowest point on our graph, and that will definitely give us a parabola shape. But how can we get to that vertex? Well, let's think about that parabola, right? That parabola is a U-shaped graph, and it's kind of symmetrical. And we have a key feature called the axis of symmetry that helps us when graphing these points. Our axis of symmetry has to lie between our x-intercepts, negative 2 and 6. They have to lie evenly, right? Because those points are evenly the same distance away from our axis of symmetry. The axis of symmetry is also connected to the vertex because we know that it goes through either the minimum or the maximum. So that axis of symmetry is going to give us a lot more information. So how are we going to figure out that point? Well, let's keep going. Well, because our axis of symmetry is going to sit right in between our two x-intercepts, we're going to find what's called the midpoint. What is that middle number that those 2 points are evenly away from? So that means we need to find the midpoint. So we're going to take those two values, negative 2, and add it to 6, because our average or our midpoint is taking 2 points, adding them, and then dividing by 2. Okay? And then we know that 0 plus 0 divided by 2 is going to be 0. So we already know that our point is going to lay on our x-axis. Well, what is negative 2 plus 4 plus, I already said the answer, negative 2 plus 6 divided by 2? There, Courtney, you already said it. 4, 0. Okay? That is not correct. Making mistakes all day, y'all. That is 2, 0, right? Awesome. So because I know that 2, 0 is where my midpoint is, I'm going to come to my graph and I'm going to say that this is 2. And if that is 2 and that is my midpoint, that is halfway from 6 and halfway from negative 6, that means that is where my axis of symmetry lies. And remember, an axis of symmetry is an equation. It is not a number. It is an equation. It is a line. And that is x equals 2. Okay? Now we're almost there. We have another piece to add to our graph that can help us connect this bridge and give us a curved U-shaped parabola. But we need to know that vertex. Well, remember, the axis of symmetry goes through our vertex. So we already know that 2 is probably going to be the same x value for our vertex because it has to be on this line somewhere. But what is that y value? We're not technically sure yet. Well, how can we find a y value when we're given an x value? Ding, 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 ding. Plug it in, plug it in. We're going to plug it back into the original equation. And we're going to figure out what is that outcome. What is the y value to give me my vertex to create my parabola? So let's go to the next slide. All right, so we have our vertex. We know that it's going to be 2, the x value rather, but we do not know our y value. So we're going to take our x value and we're going to substitute it into our equation. So we have y equals 1/2 parentheses x minus 6. So here that x is 2 minus 6. And then we also have x plus 2. So then we go 2 plus 2. Okay? And we're solving for y. What is my y? Well, that means we are going to put our values in our calculator, on our phone, or in our head, because this is really easy, simple math, and we're going to figure out what our y value equals. So I have 1/2. 2 minus 4 is -4. 2 plus 2 equals 4. Then we have -4 and 4 times half. We're at half times -16. We multiply those two numbers together and we get -8. Or I hope you got -8. And if I'm wrong, fight. LOL. So we have -8 is our y value for this vertex. So we're going to add that up there to our point. And then we are going to box out our answer for our vertex so we can see it really clearly. We kind of messed up. So let's just box it like that. So now we're going to plot that point on our graph, sketching it, of course, to -8. And I'm going to use green so it can match that. So my vertex is 2, so I'm coming over here. But I'm going to -8, so I'm going to just make up that -8 is right here. So that's the cool thing about a sketch. You get to, and I'm making a little bit of mistakes, but that's okay. You get to literally write wherever you think that number is on your graph. And I mean messing up, Miss Meekins. Okay. And then you plot that point there at 2 and -8. And now we can actually say that we can graph our parabola by connecting these 3 points in a U shape. So let's see if I can sketch this. There we go. Coming through the vertex, coming to the other x-intercept. And we always like to add arrows because it's opening up and it's continuous. Doesn't have to be perfect, but we did just graph a quadratic function using factored form. So if you've gotten this far and you're still a little confused, I definitely want you to go back to the slides beforehand to make sure that you can understand this video completely. There's also another video attached in the link if you need that help. I'm going to give a recap on the next slide, and then you are free to go and succeed. All right, I will see y'all soon in the next video. Toodles.